All right, guys. Chapter 4, we kind of started yesterday talking about what a triangle was. It's stuff about its angles. But the big focus in Chapter 4 is about proving congruent triangles, which we're going to kind of get a little exposure today. Not a lot, but we're going to get a little exposure. First of all, we know what congruent means.
Mm-hmm.
But what if I'm talking about two figures being congruent? Kind of get me a general idea. Like, what would have to be true for two figures to be congruent?
Okay, well, so far we've talked about like segments and angles being congruent. So like if two segments are congruent, they have the same measure. If two angles are congruent, they have the same measure. So I'm thinking if figures were congruent, would that mean that all of their sides and angles are all the same measures?
Okay. So essentially, like, they have some of their sizes, like all everything in it, all their sizes are kind of the same compared to one triangle or one. Let's say we could talk about a pentagon and another pentagon. A lot of times, what I like to kind of think about first is you can't compare like a triangle and a square, of course. So they have to have the same overall shape. Okay, that's kind of a no-brainer.
Right.
But we have to have the same size as well, which is what Ms. Hochgrabe is doing, is elaborating on this. So she's talking about the fact that they have to have the same angle measures and same side length measures, which is good. Within like the figure, so if I'm talking about two figures, like let's say triangles, does that mean all the triangles have to have all three sides that are congruent?
No, I would just think that like if one had a side length of 5, the other one should have a side length that's also 5.
Okay.
But they don't all have to be 5s.
Okay. Let's use a word that kind of matches those things up.
Okay.
Okay. Think back to, we've used a word before. Like when you were wanting to match things up, what word did we use? Like with the angles last chapter.
Oh, like with angles, when I saw angles that were in the same location kind of a thing, those are corresponding.
So if you're talking about same size, we're talking about the corresponding. You said angles, right?
Corresponding angles and sides, really, right?
Okay, are going to have to be congruent, and their corresponding sides have to be congruent.
Okay. All right, so that makes sense. So if I've got two triangles, they have to be both triangles. I can't have a triangle and a square, so same shape, but all of those parts within there, the corresponding parts, I like that word, corresponding parts, have to be the same, have to be congruent.
And when she's talking about parts, these are the parts. A figure has angles and sides, so the corresponding parts have to be congruent. Not just all of their parts have to be congruent, the corresponding things that match up.
Okay.
All right, so that's kind of just to give you a brief kind of definition of it, which leads into, notice the next slide, it actually starts off with saying that, so just a reminder about that.
So starting off with the correspondence between two figures. Corresponding angles are congruent, corresponding sides are congruent. Notice again, all those parts, those corresponding parts, are congruent. So looking at the two triangles that we have here, I've got lots of things marked on them, lots of tick marks. Which sides and which angles would be considered corresponding? Let's start with just the angles. Mrs. Palermo, when you look at these two figures, how do I know which angles are going to correspond?
Well, I know that, like, I look at it, I'm like, well, it looks like angle T and angle E kind of they look like they're in the same location. However, looking at the tick marks, those aren't the ones that are labeled congruent.
Right.
So we're looking at the tick marks, like Ms. Hochgrabe said. So the thing is that the way that the figure is drawn could be kind of rotated a little bit, could have moved. It's not necessarily based on how the picture is drawn exactly, like location. You got to look at those tick marks.
Right.
So I would say the things that correspond. So starting with angle T and the left triangle, I would say angle T and angle, let's see, Z have the same amount of tick marks.
Right, they have the same amount of tick marks. They both have 2 tick marks. Perfect. Okay, so then what other corresponding angles do you see?
Angle B has 3 tick marks, and angle E also has 3 tick marks.
Awesome. And
then angle A and angle C. And the fact that we're talking about 2 triangles, we're going to have 3 pairs of congruent angle pairs there.
Every time, yes. Okay, what about the corresponding sides? What sides here do you see?
Okay, so looking at tick marks, side AT, which is segment AT, and segment CZ.
Right, and you notice that those were because they both had what?
One tick mark.
One tick mark. So looking for those congruents that you see, because all the corresponding sides will be congruent to each other.
And again, guys, don't just look at how the picture is drawn. Look at the tick marks, because that's going to be a big factor in a lot of things we're going to get to. All right, let's go to 2 tick marks. Segment TB and then segment EZ. And then finally, segment AB and segment CE. So with 2 triangles, will we always end up with 6 congruent parts?
Sure,
basically?
because you're going to think if all the angles, all the corresponding angles are congruent, there's 3 angles in each, and all the corresponding sides, and there's 3 sides in each triangle as well. Now, congruent statement. This is a way to talk about those triangles. Would you agree that, first of all, these triangles are congruent?
Yes, because they have 6 congruent corresponding parts.
Right. So when we're writing a congruent statement, we want to talk about what triangle is congruent to what triangle.
Okay.
Now, what we need to be careful of when we're writing a congruent statement, the important thing here is that we want to keep them in their corresponding order. So keep all of our parts, all the corresponding parts, in order.
Okay, that makes sense. So I'm essentially naming the triangles, which we talked about yesterday, but how I name it will kind of depend on like the order. So how I name the first triangle probably won't matter, right?
Right, but the second triangle will. So let's start, just name the first triangle.
So let's say triangle ATB.
ATB. Now, I want you to notice where you've got these things kind of in relation to how it's named. So you started with angle A, really, the vertex of A. A is the piece that has the 1 tick mark. So when I start to name the next triangle that is congruent to that, I need to make sure that that corresponding part is in its same location. So if I started with A, what do I have to start with on the second triangle? C, because it has that corresponding 1 congruent tick mark.
And Ms. Hillgrave is like going back to the picture. Could you go back to like how we listed out the corresponding angles? Kind of notice that the A and the C matched up, angle T and Z, and so on and so forth.
Definitely.
So the fact that I went from A then T, I noticed T matches up with Z, so that has to be next. And then B was the next on the ATB, so E would be the next on that triangle.
Perfect. I'll tell you guys that when you're making a congruent statement, you really the first thing that you list, it won't matter. But when you name your second triangle, it does matter. The order matters, and it has to be to where you have those corresponding congruent parts in that same.
And you could look at the sides as well. Notice that the first 2 letters, AT, should match up with the first 2 letters on the next one, which was CZ, and then TB and EZ, and so on and so forth. It's this is, again, we're going to be writing lots of congruent statements in chapter 4, so get comfortable with it. Now, speaking of a congruent statement, notice this go around. I'm just giving you a congruent statement.
Right.
So what the question is saying is, let's name some congruent parts. Now, when I'm talking about parts, what am I talking about?
That means all the congruent angles and all the congruent sides.
And because we're talking about triangles, we're going to have 3 of each here. Okay. So what do you want to start with?
Let's start with angles.
Okay. So I'm just going to make a little note. We're going to start with the angles. And so we're going to name the corresponding congruent angle pairs.
Okay. And we know that with the congruent statement that the order of these things matters. So when I talk about angle C, I know that that has to match up with angle M because they're in the same location of that congruent statement.
So these would be congruent because of the fact that they're in the same location in your statement. The statement kind of gives it away.
Right.
Now, you could draw a picture to kind of get a visual of these 2 triangles, but I really like what Ms. Hokery is doing because it's, bottom line, it's less work involved, and she's just understanding that congruent statement because that's really what this statement is saying. It's telling you what pieces correspond.
Okay.
All right, so
let's angle A would be congruent to angle J, and angle C would be congruent to angle
did C, I think.
Oh, sorry, T. We did, thank you.
That's all right.
Angle T would be congruent to angle R.
All right. There's 3 pairs of congruent angle parts there. Let's do the sides.
Okay, now for sides, I'm going to start with CA because I see that those 2 are right next to each other. So segment CA is congruent to segment MJ is in that same location.
Now, could I say JM?
Well, yeah, I could, but I want to keep those I'm just going to keep those corresponding pieces in that order.
It won't matter because it's the same segment.
Yeah. Okay. What about, let's go with AT. So now I'm using that middle and last letter. So I'm going to use the middle and last letter of the other congruent statement. So JR.
So these two segments are congruent, and we have one more.
And, okay, I haven't done CT yet, so doing first and with the last. Yeah. CT will be congruent to segment MR.
And again, if you need a visual, and it doesn't say what kind of triangle, so you could say triangle CAT, and then draw another triangle MJR. Notice how I label it the same as my other one, so I could easily see what kind of matches up.
Yeah.
All right. So that's another option. You don't have to draw a picture, though.
Okay. So now in this next example, it says we're given that we have two, and in this case, are these triangles?
No, these look like the four sides, so it'd be a quadrilateral, right? So we can still do kind of use what we know about congruent figures and apply it to more sides.
We can apply it to any number of sides. All right. So we're given the congruent statement. We are given that quadrilateral ABCD is congruent to KJHL. We're supposed to find the value of X, and we're going to find the value of Y. Now, what I want you to look here is, first of all, what pieces do we know correspond?
Well, the congruent statement basically is telling you like which angles are going to correspond, which segments are going to correspond.
So let's mark our picture with some of that.
So I look and see angle A and angle K are going to be congruent. I like this idea. And then angle B is going to be congruent to angle J. So right away, like I noticed A and K, there wasn't anything labeled about it, so that's probably not going to help us. Right. But I noticed B and J have angle B is 86, so I could technically go ahead and label J as 86. If who knows? I might need it. I don't know.
I love this idea. Okay, keep going.
So angle C and angle H.
And again, you're getting this just by looking at the congruent statement. A with K, B with J, C with H, just making sure everybody's seeing that.
D and L.
And I'm going to real quick, you said H.
So that's 91.
It has to be 91. Love it. Okay.
And then D and L are going to be congruent.
Ooh.
So that, because I noticed you mentioned earlier that we're going to find the value of X and the value of Y, I see that Y is involved in that angle L.
Yeah. And
then it's the same measure as angle D since they're congruent. So I could go ahead and say 5Y minus 12 is equal to 113. So now I'm doing the second thing they asked, but who cares what order, right?
Right. And because we started with angles, that's the piece that I would think we would see first. If we started with segments, because I know X is part of a segment, when we get to that, we'll see that in a minute too. All right, so let's go ahead and let's solve for Y.
Okay, so then 5Y is equal to 125, which means Y will equal 25.
All right, so again, looking up here, we found the value of Y. Y is 25. That's one piece that we've done. The other thing they asked us to do is find the value of X. We so far have only talked about the angles being congruent. Let's talk about segments for a minute. Now, we can label all of these segments, but what I'm hoping you realized after what we just did was that we wanted to try to find a set of, on the last one, a set of angles that corresponded that include this 5Y minus 12 to help us to solve for Y. Where is the piece that has the X?
Well, that's part of the segment KJ.
Okay, so let's go back up here and let's look where segment KJ is. What would correspond with that?
AB. So really, that's the only thing we need to look at. So AB and KJ will be congruent because those are given congruent figures, so we can set them equal to each other.
Yes. I want you guys to realize that you can find all of those corresponding congruent parts and mark them in your picture. But when you're just solving for a variable, look for what piece does that variable correspond to.
So that equals 9. I'm going to solve for X equals 12, X equals 3.
And there's our value of X.
So that congruent statement, the last two problems we've done, they were giving you a congruent statement, and then you used it to find some information out.
Correct.
Right? Now, before we get to the next concept, there is a new theorem we're going to learn. I have a picture up here just to get a visual, kind of a preview of where you're going. Now, before we get into this, now I look at these, there's obviously two triangles. they don't even look congruent, do they?
No.
Like one looks bigger than the other. So this one doesn't involve congruent triangles. So this is a little bit different. This is going to help us maybe be able to prove congruent triangles with some information.
Okay.
Now, when you look at it, notice that in each of the triangles, they give you 2 angle measures.
Right.
Okay. And notice the 2 angle measures in this one, they correspond here. And notice, what do you notice about them?
Oh, that they're the same as in the other triangle.
Yeah, so this angle F is the same as this angle G, right?
Correct.
And angle D is the same as angle Y. Now, could we find the missing angle in each triangle?
Sure, we learned the triangle sum theorem.
So the triangle sum theorem, all the angles add up to
180 degrees.
So if I add these 2 up and then take that, basically subtract that sum from 180, you get how many?
Yes.
How many degrees? How many degrees do we get? Add those, I'm sorry.
That's it. You would get a total, you'd be left with 65.
Okay. And if I do that the same over here, what am I going to get?
65. It's the same math process.
Yeah. So what's the point of this? Well, notice if I give you 2 triangles where I give you basically 2 sets of corresponding congruent angles. You see that?
Yeah.
What do you think we'll be able to conclude about the remaining third angle?
That they're the same.
Yeah. So this is going to lead into this theorem. All right. Notice the name. It's called third angles theorem. This is not a direct relationship to proving congruent figures. This is just
those last 2 triangles didn't look congruent.
It didn't have anything to do with it. So let's read the theorem. It says if 2 angles of one triangle, so we have 2 angles of one triangle, this has to deal with triangles, this doesn't deal with any type of other figure, are congruent to the 2 angles of another triangle. So in this picture, notice what I have.
So angle A is congruent to angle D, and angle B is congruent to angle E.
Which basically means we can then conclude what? The third angles of those figures are congruent. So what would be congruent?
So angle C would be congruent to angle F.
So third angles theorem is not going to be used all the time, but it's something that could help us prove another pair of congruent angles, which is helpful when we start proving congruent triangles because you're going to need those congruent pieces listed. All right, so that's really essentially what this theorem is about.
Sounds good. All right, so we've got an example here where, notice that, what do we have in this picture? We have 2 triangles that have what?
There are 2 pairs of corresponding congruent angles.
All right, so what do we know about the third set of angles?
The third set of angles will be congruent. So that means angle A will have to be congruent to angle F.
Right. So using that third angles theorem, we can say that. All right, now, I'm going to go ahead, because right now I don't have enough in any one picture to necessarily go too far. I have enough in this picture to find out what A is, but that's not really what I'm finding. But what do we know about A? How could I find A?
Well, the angles in any triangle add up to 180 degrees. So I could find it by taking 180 minus that sum. So 87 plus 22, and take that away, and you get, is it 20? No. I don't know. Let's see. So 87 plus 22 is 109. So 108, 180 minus 109. 71.
71. So this is 71 degrees.
Okay.
Okay, so that means that if that's 71 degrees, what else do we know?
That is also 71. So we could do 4x plus 15 equals 71.
Awesome. So knowing that third angles theorem, just by knowing that this has to be 71, this also has to be 71. Another way we could have done this, we could have called this 22. We could have called this 87 and said all of these together have to equal 180 degrees.
Yeah.
So a couple ways that we could have approached this problem.
So x ends up being...
Oh, okay. We're going straight to X.
Yeah, let's just
Go
answer it. X ends up being 14.
All right.
You guys know how to solve that.
You can solve it. So then, and that's all they asked us to do is find the value of X, and we found the value of X. All right.
All right. Now this question is going to lead us into where we're going to eventually go with proving figures that are congruent. We're going to start with they just said, are these triangles congruent? Now, the blurb up the top, it says, to prove figures are congruent, it says all corresponding sides and angles must be congruent.
Okay, so we need 6 things to really prove
if you're proving
congruent.
triangles are congruent, you need 6 congruent parts, basically. All right. If there was two quadrilaterals, you'd have to have how many parts?
8.
8. Okay. Says, if so, give the congruent statement. So one thing that we're going to want is we want you to kind of list those parts.
Okay.
Sometimes they're already given to us. Sometimes they're not. Okay, so we're going to list it. I know a lot of times they're going to ask you to explain or give justification. So we're not going to do like a formal 2-column proof, but we're going to provide kind of an explanation off the site just so we know kind of what it's dealing with.
Okay.
Now, let's start with kind of looking at the picture and notice some of the things that are kind of the obvious.
Okay, well, like, for example, I'm going to list for angles, angle T and angle J both have 58 degrees marked.
Okay.
So I know that those are going to be congruent.
So these are going to be congruent. And that's because they basically have the same measure.
Right.
Just kind of jotting that down to get an idea. Okay. Any other obvious stuff?
I would say that segment CT is congruent to segment JG, and that's because they're marked congruent.
Yeah, those was given to us. That was basically provided by the picture. Okay.
Okay.
So we've got 2 down, 4 more pieces to go. Is
Okay.
there anything else?
Well, they also made a statement off to the side that said A is the midpoint
So A is the midpoint of
2 different segments, really.
Okay, so let's start with segment TJ. If
Okay.
A is the midpoint of segment TJ, what
And
does
I
that mean?
remember a midpoint divides a segment into 2 congruent segments.
Which is helpful.
So that means that TA, segment TA, should be congruent to segment AJ.
And
So that's definition of midpoint.
definition of midpoint. Just in case, this doesn't say explain, but if I can't remember if the classwork is asking us to do that. So this is just to give us an idea.
Okay. And then if A is the midpoint of CG, then I know that it's dividing that segment into 2 congruent parts. So that means that CA would be congruent to AG. And that is another definition of midpoint.
So the same reason here.
Same reason.
Okay.
Okay, now I've got all 3 of my segments that I've got marked now.
Yes.
But I notice I only have 1 set of angles. But I'm looking at the picture, and I noticed that I've got some vertical angles.
Ooh, we know stuff about vertical angles.
We know that vertical angles are congruent. Now, I can't call them just angles A because I know that there's lots of vertices, lots of segments coming off
there
of
are
A.
basically several angle A's in that picture. So this is, I would say, don't you think it's a pretty common mistake that people like to do? Is
Yeah, they just want to call it A.
So if there's more than one angle at a vertex, we need to name it by
All 3 points.
all 3 points. So let's name these
angle
angles.
CAT is congruent to angle JAG. Oh, love that little cat jag reference. Okay. And I'm guessing that those
This is
third
vertical
angles,
angle theorem, right? Vertical angle theorem.
vertical angle theorem, those third angles have to be congruent using that third angle theorem.
Since we have 2 pairs, this triangle has two angles that are congruent to this triangle's 2 angles. That means which angles are going to be congruent.
So angle C is congruent to angle G.
And this is your third angles theorem. We can just abbreviate. And I'm moving a label in the picture. So is that enough information to answer this question?
Yes, those are congruent triangles because all 6 of those parts, all 3 angles and all 3 corresponding sides, are congruent.
All right, so it says yes. If so, give the congruent statement. So what do you think I'm looking for?
Okay, we're going to name them the triangle. So let's call it triangle CAT is congruent to, now I want to just say triangle JAG, but I've got to make sure that those pieces line up. So C, oh yeah, it does not correspond with the J.
So C
start
corresponds
with the G.
G, so we got to
Start
start
with
there.
the G. A is still going to be in the middle, and then J corresponds with our T.
Yeah, so this is one prime example that it's not drawn based on, like you can't look at how it's drawn. It's based on looking at those congruent marks. So this would be your answer, and the reason why is because we listed, notice there are 1, 2, 3, 4, 5, 6 different things that we needed to list to prove it.
Okay.
It's a lot of work to prove congruent triangles in a sense. All right?
Okay, so now these are not triangles.
No, they're not.
We want to determine, are these figures congruent, and if so, give the congruent statement. Okay, so let's talk about the pieces, and they've given us a lot already in this picture. But let's talk about the pieces that are, because now how many sides do we have to each one of these figures here?
Well, it looks like there are 4 sides and 4 angles. So
yeah,
that
4
means
sides and 4 angles. Same thing over here. What do we call those?
Quadrilaterals.
We've got quadrilaterals. Now,
Great picture, by the way.
4 sides. Yeah, I know. I took it right back off because it was really bad. But I would need to have 4 sides that are congruent. And I need to have 4 angles that are congruent to be able to talk about these figures being congruent.
And if I don't, then I can't say they're congruent.
You got it. Okay, so let's take a look at this picture. And I'm going to just say, let's start with sides for a minute.
Okay. I like that idea. I see some already. So segment TL is going to be congruent to segment GK. And this is all the pictures given this to us. So then segment HG is congruent to segment LP. Again, that's because of tick marks. And then I see segment TH is congruent to segment PK. Now there's 3. I need 4. Now the 4th, I'm noticing those 2 quadrilaterals share a side.
Yes, they do.
So they both have segment LG in both of those figures, right?
Right. So the question,
what does that mean?
Can it be congruent to itself?
Yeah, we learned a property back in like chapter 2, so a couple of chapters ago, where it says reflexive property says when something can be congruent or equal to itself, the reflexive property allows us to say that.
Yes, that's one that we haven't used very much by itself yet, because it's not necessarily helpful when I'm just talking about segments or angles, but when we start talking about figures, sometimes you'll have figures that share a common side. And when we're trying to prove figures congruent, we need to know that all of those sides and all of those angles are congruent. So if they have a common side or they have a common angle, we can use that reflexive property to be able to put those together. Okay, so we've got 4 sides. Let's look at our angles, though.
Okay, so I need 4 pairs of congruent angles. So I see the angles that are labeled are all right angles, and we know all right angles are congruent.
Right.
Now,
so let's maybe think, though, about corresponding pieces.
Okay, so I would say, I'm going to start with angle T.
Okay, so look at where T is. T is located between the 1 and the 3.
So it's got to do that in the other figure. So it would be angle K.
Perfect.
And again, because all of them are congruent, all those angles are technically congruent to each other, but we're looking at corresponding.
Right.
All right, so then, and if you needed to, like you could even label like tick marks. So that would be like a 1 tick mark, just so you can kind of get, and then angle H and angle P because they're between the 2 and the 3 tick marks of the sides.
Perfect. Now, do we know anything about these other angles?
No, so does that mean we can't say these are congruent?
Well, it's a thought, because here's the thing. If we don't know it, we don't know it.
Yeah.
But we do know something else because we've got all of these things that are perpendicular. We learned last chapter about some things that were perpendicular to the same line.
Okay.
And I want you to look at this for a minute because I want you to realize that this line TH, it's perpendicular to a couple different things, right?
So TH is perpendicular. You could say either TL or TP, that whole thing.
Yes.
And then TH is also perpendicular to segment HG. So they're perpendicular to the same line.
And what happens when two lines are perpendicular to the same line?
Then they are parallel. So that whole thing, TP and HK, are parallel. Perfect. Okay, so once I know parallel, that means I know some angles might be congruent, right?
Exactly.
Okay. So I see. Okay, so if you're looking at it, that TP, that whole side TP, and that whole side HK, all right, they have a transversal of LG.
Correct.
So within that, I see some alternate interior angles.
Yes.
So angle PLG is going to be congruent to angle HGL. And we have to name with all 3 letters because there's more than one angle at that vertex.
Right. And you said the reason was the alternate interior angle theorem. So I'm going to go ahead and add that on there.
And that's going to be the same reason for my other sets. Angle TLG is going to be congruent to angle KGL. And that's because of alternate interior angle. If there's my 4 sets of corresponding congruent angles, I have my 4 sets of corresponding sides.
So are they congruent?
Yes. So
yes.
the first part would be yes.
Get a new color so we can see where we're going.
So yes, and it says give a congruent statement. So I'm giving a congruent statement. These are quadrilaterals, so I need 4 letters.
4 letters. And with quadrilaterals, you don't need to put a little quadrilateral symbol first.
Okay. So let's name the first one TLGH.
Okay.
Now, how I correspond it, so angle T is what I started with. So that would be 1 tick mark K. And then I'm going to go to L, which is the, 4 tick marks, which means G. And then I went to 3 tick marks. G was on the other one. That would be L up top. And then H and P.
And it starts to get a little confusing sometimes because they have some overlapping, some common vertices.
Yeah.
Since those 2 pictures have a common side. But really, just like Mrs. Playerman did, look for those corresponding parts and make sure you line up those corresponding parts each time.
All right, one more example. Here we're actually going to do a 2-column proof, which is what we're going to see more in your notes tomorrow. Tomorrow night, you're going to watch notes that are going to be more on proving congruent triangles. We're going to learn
some theorems that'll make them a little bit nicer.
Yes. Okay. So I'm going to start writing down what's given to us. We know segment MN is congruent to segment OP, and QP. I might even, or QP, sorry. MN, so that's this one. QP is this one. We know some segments are parallel. Those same segments are also parallel. So that probably is going to tell us something
about angles.
Anytime you're given parallel from chapter 3, that's going to tell us about the angles. O is the midpoint of, it says, segment MQ and segment PN. So that's going to tell us something as well.
Right.
And what we're going to do is prove, let's make sure we know what triangles we're proving. I see more than one.
Yeah, there's a lot of triangles.
Or one set of triangles. It says triangle MNO. So this one right here, this triangle here. And I might even shade it in. This triangle here. And we're going to try to prove that it's congruent to angle QPO. So the fact that they're trying to prove they are congruent means they're going to be. We just need to have how many pieces to prove it?
6 pieces.
6. Do we have any pieces?
We have some. We have 1.
Okay, so we need 5 more.
Okay. Oh, boy.
All right.
All right. I'm going to start off with the, let's just go in order. We've already, let's mark somehow.
Okay,
we've
so
got
we
our
got
one
this one. We got
piece.
this piece. This is one piece.
All right, now I'm looking at the parallels.
Okay.
Parallels means that we have some angles that are congruent, possibly with some special angle pairs. I notice that we have some alternate interior angles. If I look at those parallel lines, and depending on which transversal we use.
So this is the parallel. These are the parallel. Which transversal do you want to
So let's start with MQ.
Okay, so this is the transversal she's looking at.
So I see within the triangle, because I obviously don't want to do anything that's outside of the triangle, but looking at what's part of that triangle, angle NMO should be congruent to angle PQO. Now, I could probably talk about PQM, but I know since I'm looking at just those triangle pieces, I stopped it.
NMO is congruent to angle PQO. And what's your reason?
Alternate interior angle theorem. Now, if we lose the transversal and we focus on the other transversal that we have going through there, so NP.
Okay, this one right here.
Then I see another set of alternate interior angles. So I could say angle MNO.
And notice I'm putting it in the same step because it has the same reason.
Right. And that should be congruent to angle I'll start with O, OPQ. Still alternate interior angle theorem. Yeah.
Let's see if I can...
Okay, so right now I see that we've got 2 sets of angles and 1 set of sides. So we've got some more things that we need.
There's 1 piece, there's 2, there's 3.
Okay. Now I'm going to let's just check off the parallels because I think we've taken care of the parallels.
I like it.
Let's go on to the midpoint.
Okay.
Okay. If O is the midpoint of MQ.
I'm going to get rid of these things right here.
Perfect. Okay. So if O is the midpoint of MQ, That means that it's dividing that segment into two congruent segments. So MO is congruent to OQ.
Perfect.
And that would be the definition of midpoint. Now, I'm also noticing that it was also the midpoint of PN, so it's dividing that segment. So PO is going to be congruent to ON, and that's still definition of midpoint. Okay, so now I've got, there's 4 and 5.
There's 4 and 5. And you don't have to number. This is just so we know.
No, we make sure we've got them all.
Got them
and
all.
I'm looking and I see that we've got all 3 sets of sides, but I'm missing one of the angles. And I see the angles that I'm missing, but I know the vertical angles.
Yes, so these angles are congruent to each other because of vertical angle theorem. Could you also use the third angles theorem
I
technically?
could use the third angles theorem. Good call.
And we're going to name it with the 3 letters. So MON
Is congruent to POQ. And yeah, really, I could have a couple reasons.
So vertical angle theorem, I think, is most popular.
Yeah.
Just because it's something we'll use more frequently. So that's enough. There's my 6th piece to go ahead and say that these triangles are congruent, right?
Right.
And so we would say triangle MNO is congruent. And they even give you the congruent statement, so you don't have to overthink that.
And don't change the order of that congruent statement either. If they give you the congruent statement, write it that way.
Now, what would be our reason?
Is that the definition of congruent figures?
It is.
So the definition of congruent figures says that all corresponding angles and all corresponding sides are congruent. Now, I'll tell you guys tomorrow, we're going to get to proving some triangles congruent. We're going to learn some other theorems that will give us some shortcuts.
Yep.
But if you want to use definition of congruent figures,
what you have to
you
do.
need all 6 parts.
Yep. Perfect.